Hello, welcome to another video. I will be showing you how to analyze and carry out data masking, otherwise termed as data anonymization, using Power Query. Are you new to Excel? Worry not, cause I got you. In our previous video, I showed you how you can clean your data using Power Query. I will be using data from Forage CommonWealth Bank data. Just in case you do not have any data, I have put the link down below so that you can go and download the data. The beauty about this, you'll be given certificate of participation once you are done taking the task. Now let us dive into the video. In task 1, make sure you go through the instructions so that you get to fully understand what is required of you. In task 1, you are supposed to create a data engineering pipeline to aggregate and extract insights from a data set. So you have been provided with a data set termed as supermarket transactions, and it is a CSV file. You are required to determine how many apples were purchased in cash, how much total cash was spent on these apples. And across all payment methods, how much money was spent at the Bakershire store location by non-member customers. They have specified that you are supposed to do this using Excel, but don't limit yourself. This video will be useful for those using Excel and Power BI as well. Go ahead and download your data. At the same time, you have been given an overview of the formulas in Excel, how you can sort out data, as well as how filtering is done in Excel. Now go ahead and open your data using Excel or Power BI. So this is how the data looks like. The last time I showed you how you can load data from file. Now because we had already opened data the normal way, just go ahead and load it from table. We have the range of the table, and make sure to check the box that your table has headers. Now this is what you see, the queries, applied steps, and you can decide to rename the table. Now question 1. You are required to determine how many apples were purchased in cash. We have quantity there so that we can know how many. We have our product name here, so let us go ahead and do filtering. Select Load More, then unselect everything and select only Apple. Select OK. Now under Payment Method, have only the cash. Now we want to know the quantity. Now look at how easy this is. Select on Transform, then under Statistics select Sum. And you have it 117 apples. To go back, cancel the applied step. Question 2. How much total cash was spent on these apples? To do this, go ahead and do the same. Under the total amount, then Transform. Statistics, then Sum, and there you have it as 537.02. Question 3. Across all payment methods, how much money was spent at the Bakershire store location by non-member customers? We will go ahead and cancel all the applied steps. This is the original data. Go to the store, unselect everything and select only the Bakershire. Then go to the customer type, we only have the non-members. Then go to the total amount. Transform, Statistics, then Sum. There you have it. Very simple. Now let us go to task 2. Go through the instructions. So in task 2, we are supposed to anonymize personal data within a dataset. You see those situations where you need help when analyzing data, but you cannot share it simply because it is confidential. Here's the good news, this process can help you anonymize the information that is sensitive and still get help. This was but an example. Now that we have talked about data anonymization or data masking, what is it actually? It is a technique used to hide or protect sensitive information in a dataset. Instead of completely removing the data, which might be necessary for analysis or testing, data masking obscures or masks certain parts of the data while leaving the rest intact. And what are the various ways we can do this? Number 1. Substitution, replace sensitive data with fictitious or random values. For example, replacing actual names with generic names like John or Jane. Number 2. Shuffling, randomly shuffle the order of sensitive data. For instance, shuffling the order of digits in a credit card number. Number 3. Pseudonymization, replace sensitive data with a pseudonym or alias. This involves substituting sensitive data with a reversible token or identifier that cannot be easily linked back to the original data without additional information. Number 4. Masking. Conceal part of the sensitive data while revealing other parts. For example, masking credit card numbers to display only the last 4 digits, e.g., XX1234. Number 5. Tokenization. Replace sensitive data with a randomly generated token or reference. Tokenization involves storing sensitive data in a separate secure location and using tokens or references in place of the original data. You have been provided with the mobile customer data, which is in CSV format. They recommend that you use Excel or spreadsheet. The data contains details of customers that have signed up for the mobile app in the last 3 years. You are required to anonymize this data to hide personal details while preserving any useful information for the data scientists at InsightSpark. You have been provided with the data. Make sure you download the data. You have also been given an in-depth guide to data masking. Overview formulas. How to mask data using MS Excel and Google Sheets. Ways you can clean your data in Excel. So let us open the data using Excel. Now get your file from external file. Select the item, then edit. We have the queries, the applied steps, and the name of our query. Make the first row the header. Column 1 will leave it as it is, but for 2 let us remove it because the information is too sensitive. In the date registered, let us add noise to the data. Go ahead and select on Add Column. Name, Date Registered. Date from Date Registered. Date time from Date Registered converts the existing date registered values into date and time format. Date from extracts only the date part from the converted date time value. Hashtag duration. Number. Random between -5, 5 generates a random number between -5 and 5, representing the noise, deviation, in years. Number. Random between -3650, 3650 generates a random number between -3650 and 3650, representing the noise, deviation, in days. Number. Random between -180, 180 generates a random number between -180 and 180, representing the noise, deviation, in minutes. This duration is added to the original date registered, effectively shifting it randomly by a certain number of years, days, and minutes. Done. Now go ahead and remove the column. We are going to do the same thing to the birthdate. We add noise. Now copy the code from the advanced editor. This one is easy. The add a column. Rename. Paste the M code. And change the date registered to birthdate. Done. Remove the column. In the username column, we want to produce the first and the last letter only and replace the rest with asterisks. Again, go to Add Column. Then Custom Column. Rename the column. Then Table.Add Column. This function adds a new column to a table. Username, this is the name of the new column we're adding. It will be named username. Each, this is a keyword used in Power Query to reference each row of the table. Text, start, username, 1. This part extracts the first character of the username in each row. Text, repeat, asterisk, text, length, username, 2. Here, we're generating a string of asterisks, asterisk symbol, to cover the middle part of the username. Text length, username, gives us the length of the username, and we subtract 2 to exclude the first and last characters. Then, text, repeat, asterisk, repeats the asterisk character that many times. Text end, username, 1. This extracts the last character of the username in each row. Select OK. Done. Go ahead and delete the original username column. Before we continue, kindly do support me by subscribing to my channel if you are finding the video informative. Thank you in advance. Let us continue. As for the name column, add column then index column. Start from 1. Right-click then add column from example. Go ahead and type customer 1 on the first column and Power Query will make a prediction for the rest of the rows. Then OK. Done. Rename. Move the column to the beginning, then to the right. Delete the original column as well. For the address, let us go ahead and replace with random values. So specify length, set the length of the random string you want to generate. In this case, it's set to 15 characters. Define character set. This line defines the set of characters from which the random string will be generated. It includes digits, 0 to 9, uppercase letters, AZ, lowercase letters, AZ. Generate random string. This line actually generates the random string. It uses a combination of functions. Number.random between 1, text length, chars. This function generates a random number between 1 and the length of the character set. Text range, chars, number.round down, 1. This function selects a single character from the character set using the randomly generated index. List, transform, 1 length. This function generates a list of numbers from 1 to the specified length and then transforms each number into a character based on the random selection from the character set. Text, combine. This function combines the list of characters into a single string. Return random string. This random string variable holds the generated random string. Done. Go ahead and delete the original column. On the email column, we want to have only the first and the last letters or integers and everything from @ going forward. The rest should be replaced with asterisks. Extract first character, text, start, email, 1, extracts the first character of the email address. Create asterisks, list, repeat, asterisk, text length, text middle, email, 2, text.position of email, @-3, creates a list of asterisks with a length equal to the number of characters between the first character and the @ symbol, excluding the @ symbol itself. Combine asterisks, text, combine combines the list of asterisks into a single string. Extract end of email, text end email, text length email, text.position of email, @+1, extracts the end of the email address starting from the @ symbol to the end of the string. Combine parts, the script combines the first character, the asterisks, and the end of the email address. Now remove the original column. On the current location, delete it. It is too confidential. For the residence, let us replace that with random strings. So go to the advanced editor, go and copy the code that we wrote previously for having random strings. Then paste it in the custom column. You can always change the string length. Done. There you have it. Remove that. For the employer, do the same. Job, let us leave it as it is. As for the age, categorize ages into different age groups. If age greater than or equal to 18 and age less than or equal to 25, then have it as 18 to 25. If the age is between 18 and 25, inclusive, it assigns the label 18 to 25 to that age group. Else if age greater than or equal to 26 and age less than or equal to 35, then 26 to 35. If the age is between 26 and 35, inclusive, it assigns the label 26 to 35 to that age group. Else if age greater than or equal to 36 and age less than or equal to 45, then 36 to 45. If the age is between 36 and 45, inclusive, it assigns the label 36 to 45 to that age group. Else if age greater than or equal to 46 and age less than or equal to 55, then 46 to 55. If the age is between 46 and 55, inclusive, it assigns the label 46 to 55 to that age group. Else if age greater than or equal to 56 and age less than or equal to 65, then 55 to 65. If the age is between 56 and 65, inclusive, it assigns the label 55 to 65 to that age group. Check for age above 65. Else if age greater than 65, then 65 plus. If the age is above 65, it assigns the label 65 plus to that age group. Else null, if none of the above conditions are met. Delete the original column. We will do the same for the salary column. If salary equals 0 and salary less than or equal to 20,000, then 0 to 20,000. If the salary is between 0 and 20,000, inclusive, it assigns the label 0 to 20,000 to that salary range. Else if salary greater than 20,000 and salary less than or equal to 100,000, then 20,000 to 100,000. If the salary is between 20,001 and 100,000, inclusive, it assigns the label 20,000 to 100,000 to that salary range. Else if salary greater than 100,000 and salary less than or equal to 180,000, then 100,000 to 180,000. If the salary is between 100,001 and 180,000, inclusive, it assigns the label 100,000 to 180,000 to that salary range. Else if salary greater than 180,000 and salary less than or equal to 260,000, then 180,000 to 260,000. If the salary is between 180,001 and 260,000 inclusive, it assigns the label 180,000 to 260,000 to that salary range. Check for salary above 260000. Else if salary greater than 260,000, then 260000 plus. If the salary is above 260000, it assigns the label 260000 plus to that salary range. Else null if none of the above conditions are met. Done. Delete the original column. In the credit card number, we will copy the same lines of codes. But this time around we will change the length to 4 and remove the AZ and only remain with values. Done. Remember to remove the original column. In the credit card expire, let us add noise the same way I showed you previously. Copy the code. Change the section of date registered to credit card expire. Done. We will keep the errors. Remember to remove the original column. Now let us sort the first column so that we start from 1. Done. Load it. Then you can always change the design. This marks the end of our video. Kindly do support me by getting me to 400 subscribers. And do not forget to give the video a thumbs up. In case of any queries, drop them down below.